All right, in this video, we are going to show how to make the Cyclone arcade game in or with the Circuit Playground. So if you're unfamiliar with the Cyclone arcade game and how it works, you can go ahead and take a look at that really quick on YouTube. So we just do Cyclone arcade game. Look at this quick video right here. So a lot of you may have seen this arcade game before, right? It's a big sort of bubble, plastic bubble with lights. The light races around the circle. And if you stop the button when it's in your jackpot area, you win, right? You get tickets if you don't quite make it, but we don't have enough lights on our Circuit Playground to recreate that. So really what we're trying to go for is just a light that races around until it lands on this spot here, the jackpot, and our goal is to pause it so that we can get it. We look back at our Circuit Playground, we'll notice our array of lights, and the first thing that we're going to need to do, so at this point, what we really want to start looking at are variables. We've done some projects in the past, and we may have used variables, but one thing I notice with new programmers is they're very hesitant to use them unless, as I'm teaching, I go around and I say, hey, maybe a variable might work for this, and then I show that student how it works. But I want us to all become more comfortable with using our variables without the teacher coming up to you and showing you how to use one. So if we think about getting a light to spin, the first thing that we're going to need to track, right? And if we're trying to keep track of something, then a variable is a perfect way to do that. So we're trying to keep track of the light's position on the Circuit Playground as it spins around. So I'm going to create a variable called light position, right? Notice I'm using what's called camel case here, which is no spaces, and the first letter is lowercase, and then every letter of each new word, if there were more new words here, they would get a capital letter, right? We do that because a lot of programming languages, that's just the correct way to name our variables. So light position, go ahead and click OK. And then what we can do is in our start loop here, when the game first starts, we want to set that light position value to 0. And the reason why is one of the things that sort of builds a bad habit when we first learn programming using block coding versus typed is it's easy to make a variable but then never set it to anything, which is usually not good, because if you forget to set it to something later, or if you try to do some math with it, right, you try to add or subtract to a variable that you never set to a number, well, you can't take nothing and add numbers to it, because nothing, the absence of something isn't a number. 0 is a number, but the complete absence of it is not. So if we actually pull this out of here and I switch over to JavaScript, I'll show you why it's a little easier in JavaScript to remember to name them, because in JavaScript we usually start a variable by saying something like this, right? Let, and then we can go ahead and call our variable what we want, which was light position, right? So let light position, and then we usually put an equal sign to set it equal to something, and then we'll say 0 and then put our semicolon to finish it, right? So it's easy to remember to put a number to our variable, because this is how you create a variable pretty much every time. You wouldn't really just say let light position, right? If we read this as a sentence, it wouldn't even make sense. Like let light position what? Right? So we always say let light position equal, and then we would call it whatever we want to call it. Anyway, we aren't going to talk about typing our code just yet. That'll be further along in the course, but there we go. Set light position to 0. So we want to make a variable and then set it to something immediately. Usually 0, but not always, right? In Mario Brothers, we would usually think of a couple of variables that would start the game off, and score would be set to 0, right? As soon as you power on the Nintendo, with Super Mario Brothers loaded into it, the variable for score is going to be set to 0 because you're going to start the game with no score. But if you think of the variable that's going to be keeping track of Mario's lives, that's going to immediately be set to 3 because usually you start Super Mario Brothers with 3 lives, right? Same thing with Pac-Man or any other, most of those older games. 0 score, 3 lives. That's how it went. Anyway, so now that we have light position set to 0, in our forever loop, we can start to make this variable do something, right? So if we go to light and we go to set pixel color at 0 to red, we watch the emulator here for the circuit playground. And of course, the light at pixel color 0, this is position 0. So the way this code works is just putting a color, right, which is the last part, at a pixel color's position. So set pixel color at that 0 is the number of its position on the circuit playground. So if we look over here, right, that's going to be 0, and then that's going to be 1, and that'll be 2 and 3 and so on all the way up to 9 over here. So there are 10 lights on the circuit playground, but because we start numbering them at 0, which is something we do in programming all the time, we always start counting by 0, or counting with 0, then this one is actually number 9, even though there are 10. Okay, so this number is at 0, and my variable is set to 0. So if I put the variable light position, then this is going to be equal to whatever we put in this box. So this right now is equal to 0. So the light shouldn't change when the emulator updates, and it doesn't. But the reason why we do that is because now I can't do anything to this number when it's just a number. When it's just a white background with a black number in it, I can't really do anything with that number once the program starts. I can come in here and reprogram it to 1. Now the light should be over here. And I can come in and reprogram that to 2. But computer programs wouldn't be very useful if I had to rewrite them every time, right? Kind of like the difference between like a book and a TV show, I guess, right? You read a book, when you put the book down and then you pick it back up, the book's going to say the same thing every time. But when you go to watch a TV show, then every time you go back to that show, you can get a different episode. I don't know if that metaphor works out because I guess you could say episode 1 is always the same. Anyway, the point is this variable can change, right? And we don't want to have to go back in and reprogram that number every time. We want to be able to change this variable by doing some math with it. So light position was set to 0 at the beginning of our program. What if in our loop, every time we get to the bottom of our loop, we add, right? So we do some math, or well, in the variable, we don't have to do any math because we have this block here, which changes the light position by 1, meaning we take whatever number light position is, which at this point is 0, and we change it by 1, meaning we add 1 to it. And of course, 0 plus 1 is 1. And then when we reach the bottom of the loop again, we'll have 1 plus 1, which of course will be 2. And then we'll have 2 plus 1, which is equal to 3, and so on. So let's do that. And we should watch what will happen here, which the array of lights fills all the way up. Let me refresh that so you can watch that again. So what's happening is at the beginning of our program, we're setting our variable to 0. We're lighting up a pixel at the position of the variable, which is 0, to red. When we hit the bottom of the loop, we increase that number by 1 so that when we start the loop again, we light up number 1. Then we add 1 to 1, which is 2, light up number 2, and so on, all the way up to 9. Now it looks like our program stopped here, but our program is still running, which means we're constantly adding by 1. But the problem is that when this gets all the way to 9, so it's lighting up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm telling the program to add 9 plus 1, which is 10. And it's still running. So who knows what this variable is? Probably some number that's very, very high, right? 100, 200, 300, whatever. But what's happening is we're telling this to light up pixels that aren't there. Because when light position is equal to 10, we're saying set pixel color at 10 to red, but there's no 10 light to light up. Same thing with 11 and 12 and 13 and 100 and 200 and 500 and 900. And if I let this program just continue to run, eventually the circuit playground would just run out of memory because it would keep adding and adding and adding numbers until we're adding a number so big that, excuse me, that it won't fit in the computer on the circuit playground, and then the program will just crash and we'd have to reset it. So that's obviously a problem. So we need some way of changing this number, of editing the math on this number so that when it reaches 10, when it goes from 9 to 10, it says, no, we can't have 10. Let's get back to 0. But we're not going to do that just yet, because the first thing that we want to do is actually, let's get these not just to turn on, but to also turn off. So I'm just going to duplicate this first line here and put this to black. Black actually isn't a color of light. It's just the absence of light. It's off, basically. So we'll click that. And let's see what happens. So it's probably a little too fast for you to see here. Actually, it looks like nothing's happening because it's lighting them up and then turning them off so fast. So we're also going to need some way of pausing that. And as we do more programming, I want you to know the sort of similar words here, right? We have pause. You might also see wait. You might also see sleep. Those all usually mean the same thing. So we'll put a little pause after the turning them on and turning them off. And now we'll notice that turns them on, turns them off. But we still have that issue with it counting above 9, which we don't want it to do. So if we don't want it to go above 9, now is the perfect chance for an if-else statement, right? Because we're going to say we want it to keep counting up from 0 to 1 to 2 to 3 to 3 to 4, all the way up to 9. And then as it counts up, if, right, keyword there, if the number, our variable, ever gets bigger than 9, reset it back to 0. If our number is greater than 9, with our number being light position. If light position is greater than 9, then set light position back to 0. And let's watch that go. And that solves our problem perfectly. Because if we stop this here for a moment and we just read our code out loud, always a good idea to read your code to yourself as you work through it. If you're in class, you know, of course, maybe you want to do that in your head. You look like you're a little weird if you're just reading your code out loud in the middle of class. But yeah, if you're at home, I do it all the time. Always helps us to catch things when we read it out loud. So in the very beginning of the program, we set our variable to 0, and then we say set the pixel color at the light position, which is 0, to red, then turn the pixel at 0 to off, and then add 1 to that. So 0 becomes 1. Is 1 bigger than 9? Well, it's not. So we don't even do what's in here. And this is a really good time to talk about what are variables and what do they do. We've used them in class before, but I want to take a moment in this video to really talk about how they work. What are they conceptually, right? And one really great way to think about variables is they're a box, right? Think of the computer in a room. I like to think of a computer in a room, and it's got these boxes in front of it, and along with all the other things that the computer's trying to do, right? Every time you make a variable, you're taking a box and you're just putting a name on it. You're labeling that box. And one thing that I think a lot of students get hung up on it is the name. Because I called this light position, doesn't actually have anything to do with what the variable is doing. The word light position is for me and anybody else who might read it, right? So it's for me and it's for you. But as far as the computer is concerned, it doesn't care what this name is here. You can sort of think of it like if we're going back to boxes, if your parents told you that you have to, that we're moving, right? We're going to go and we're going to move to Alaska for whatever reason. I want you to pack up your room. So they give you a bunch of boxes, bunch of cardboard boxes, and they say, pack up your room. And if you're a mature student, if you're a mature kid, hopefully you're going to go and you're going to take those boxes, you're going to label them, right? Clothes, video games, movies, whatever. If you're an artist, maybe you got some art supplies, bedding, yada, 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 right? So you take your stuff, you take your boxes and you label them. But because you labeled the box clothes does not mean that the universe is going to force you to put clothes in that box. You could still put anything you want in that box. It would be weird if you put something that wasn't clothes in the clothes box, but you're free to do that, right? And when you pack all your stuff, you put it in the truck, and you tell the driver, the moving van guy, to go and move them up to your new house, right? And that's sort of like the instruction in the computer, like move these boxes somewhere else, and then I'll open them. That's all still going to happen regardless of what you named the box, right? The same thing with this variable. I can call this whatever I want, and I can do whatever I want with it. Just because I called it light position does not force me to do anything with lights. It's just a good idea for me to do so. Keeps things organized, right? So now, going with the box example, right? I told the computer, take an empty box and go ahead and stuff the number 0 in it right here at the very beginning. Then, right here at the very beginning of our loop, we're going to look inside that box and we're going to see what numbers in the box, right? The computer isn't smart enough to remember what it was. It has to do it. It has to be told to look in the box and see what the number is. And at this point, the number is still 0. And now I'm telling it to say, okay, there's a 0 in that box. I want you to use that 0 to light up the pixel position at 0, that number you took out of the box, and make it red, right? And then I want you to pause for a little bit, a hundredth of a second there. And then I want you to take the box out again, open the box up, look at the number inside, and then turn off the pixel at that position, which is still 0. Then I want you to open that box and look inside. And there's a 0 still inside. Then I want you to take that 0 and I want you to add 1 to that 0. And then I want you to take that answer, 0 plus 1 is 1, and then stuff that 1 back in the box. And the 0 just goes away. So now we have a 1 in the box. At this point, we look back in the box and we say, what's in the box? It's a 1. Is 1 greater than 9? It's not. So then we just don't do this. We just don't do it at all. We skip it and we go back to the top. And we repeat that whole process again. And that's going to stay the same, right? 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 9, right? So it'll light up the 9th pixel, the pixel number 9, which is the 10th pixel, the last one. It'll light it up red. It'll turn the last one off. Then it will take that 9 and add 1 to it. And now it's 10. And now when we tell the computer to look in the box and it has a 10 in it, it asks, is 10 greater than 9? And it is. So now we move on to this line of code. So this line of code only happens once every 10 times because it gets skipped every other time. But when this number is finally not 10, it's finally going to say, okay, take the 10 out of the box and put 0 back in it. Put that 0 in. And with the 0 in it, we can now start our loop again. And that's how we get this loop. And that's how you need to think about variables. Variables are just boxes, which can really hold anything. And we'll see that more as we go along, but that explanation of variables was already a little long. So let's continue. We have a light that goes in a loop, which means we really have most of the program that we need here. We need to be able to stop it now though, right? And our first instinct might be to go in input and, use the A button or the B button and just say, I don't know, set all pixels to off, right? There you go. And if I click this button, sometimes it turns off. If you're looking at it, I'm just mashing this button. Sometimes it turns off, but obviously this forever loop is still going on, right? And that's because there's just no communication between this instruction here to turn them all off and this instruction here to keep looping them, right? If as a person, as a human that can, sort of take context into account, I can, if somebody were to tell me, okay, go into this room and turn the light on and off constantly. And then if the next thing they told me was stop doing that, like, so, turn all the lights off, I would just assume that they wanted me to stop doing the first thing, which was turning them on and off, and then just turn them off, right? But a computer can't do that. You have to specifically say, we need to stop this and do this, or else it's going to try to do both. So we need a way of not just setting all the pixels to off, but a way of stopping this loop here, or else it's just going to take right over. And a really good way on the Circuit Playground emulator here to see that is if we click the snail button, because the snail button is going to go through our code very slowly and highlight in yellow what's happening. So here we could see it jumping through that process of adding 1 to the number, turning on, turning off, adding 1 to the number, turning on, turning off. And if I press the A button, watch the yellow light, turn all the pixels off, then we jumped right back into this loop. I'll do it again, right? So you can see this loop is sort of, it's marching forward throughout this whole process. So remember I said that if we want to keep track of something, which in this case we want to keep track of, whether the button was pressed or not, right? We want to keep track of when we need to stop this loop. We're going to need a variable. So let's go ahead and call this variable a pressed, right? I like variables that ask a question, a pressed. So we can think of this as having a question mark at the end of it. We don't want to do that because in JavaScript, you can't put a question mark in a variable. I don't think, actually, that I could be wrong about that. So it might be possible, but definitely not recommended at the very least. So we're just going to assume that that's a question because it would be asked like a question, right? A pressed. Was it pressed? Have we pressed A? The reason why I like variables that ask questions is because we can limit these variables now. Sorry about that. We can limit these variables to now either a 0 for no and a 1 for yes, right? So 0 is no and a 1 is yes. So when we first make a variable, remember that I want you to always set it to something. And at the start of the game, the A button, the A press should be at 0 because, not many people would hold the A button down while they turn it on. Usually not jamming buttons when you're booting up your game, right? So we're going to set it to 0 at first. But then when the A button gets pressed, we're then going to set it to 1 because it got pressed. And now this loop here, we are only going to do when the A button, when A pressed variable is at 0. So there's two things we could do. Functionally, these would be the same. We could use an if statement, or we could use a do while loop right here. So let's do while, right? So do while A pressed equals 0. When this boots back up again, it should still be doing the same thing. But when I press the A button, it stops. So now I have a way of stopping the light. And if I want to turn back on the light to see where I stopped it, I can light up the pixel at light position to red. And I can stop it right where I stopped it. Except for that time where it didn't do it. There we go. We might need a tiny little pause there because sometimes this code doesn't stop immediately, at least on the emulator. I'm pretty sure in the circuit playground it does a pretty good job of that, but on the emulator it's not always perfect. So we'll actually just take a really quick, maybe a tenth of a second pause right there. No, that still doesn't do it every time. So maybe we increase this a little bit. There we go. Let's try that a couple more times. Yep. Nope, still not perfect. That's okay. We'll worry about that a little later. But what we want to do now is have a way for us to win, because now we have a game that loops it, stops it, but we also need one where we can also say whether we won or not. So whether we won or not is definitely going to be a question where we ask if, right? Because if we won, we want to play some happy music and maybe some happy lights. And if we lost, we're going to want to play some sad music and some sad lights, right? So let's go ahead and take our if statement out and say if, and when did we win, right? Well, there's two ways to say that if we won. We could say, we can check a pixel's position, right? So if pixel color at, and then we can choose one of these lights here. If pixel color at, and then a certain light is equal to red, since that's the light that spins, then we won. But probably a little bit better would be to say, because we're already tracking, we don't have to track it by color because we're already tracking it by number, and that's the light position. So if light position is at the position that the target that we choose, then we won. So we could say if light position is equal to, and now we can just choose a light position. Let's choose 0, 1, 2. It's closest to the A button, and the A button even has a little arrow. I don't think it's not for that intended purpose, but we could say that it was. So if light position 2, if light position is equal to 2, then we can play some happy lights and play some happy music, which you won't hear. I have my computer sounds muted while I do this, but for you guys out there, maybe botting would be a good one. So we want to stop it at 2. And there we go. So we're actually not going to need this little light thing that wasn't working anyway, because we're just going to have it immediately tell us whether we won or lost. So there we go. If we won, happy lights. If we didn't win, right now, nothing. But since we win only on one light and lose on all the others, we don't need another if condition for anything. We would if we were creating the Cyclone game perfectly, because then we would want light position 1 and 3 to maybe have some sound or lights that they designated that we got close but not quite or whatever. But we're not going to do that. So we're just going to say if we landed on anything other than 2, then we lost, which is just a simple else statement. So here we can say play sound wah wah and show some sad lights, which in this case would be the red animation. And now if we win, yay, and if we lose, boo. Now, how is the player supposed to know they're supposed to stop on 2? I know that we're supposed to stop on 2 because it says it in the code, but the player won't. We can't assume the player can read code, and even if they could, when they're just holding the circuit playground, they won't be able to see this screen. So let's find a way of getting this light to always light up. And that one should be pretty easy because we can just set the pixel color at 2 to be, some color. Let's make it yellow. And I'm gonna actually put this right after we turn it off. So now it's turning on, turning off very briefly, and then right back to yellow. So you actually won't, unlike all the other lights, the player won't even really see this turn off because it's happening so fast, the code's just jumping right to yellow. So in this case, this light is pretty much always red or yellow. It's never actually off, where all the other ones will get turned off. And now we have a good way of seeing where we need to stop and where we lose. All right. So now, what else do we need to do? We need to get the game to reset. So because when I pause and the animation happens for losing, or when I pause the light and the animation happens for winning, it just ends and that's it. So remember that these 2 bits of code here need to communicate, and they're communicating now with this A pressed, the do while A pressed is 0. But then we set A pressed to 1, and then we never put it back, to 0. And really it is as simple as that. If we put A pressed back to 0, this do while loop will fire back up again and we'll be ready to go. So all we have to do is duplicate this and put it at the end, but changed 1 back to 0. Now the only problem here is the animation stays and gets wiped away once it hits this the turn red and then turn black. So I'm also going to copy the clear pixels here, the turn them all to black pixel here. That way it starts right back up again. Now I think that 500 milliseconds, which is just half a second, is probably a little too small of a break in between playing the game, winning or losing and then starting back up again. So let's just increase that a little bit. We'll make that 2 seconds. Give our player a little breather between rounds. Let's try that and see how that feels. Win. And back again. Lose. And then back again. I think that's pretty good. 2 seconds. So that's pretty much it. We've got Cyclone. It plays forever. I could put this code into a real circuit playground and carry it around school and play all day if I wanted to, pass it to my friends and they could play. Probably, admittedly, not the most exciting game, but I think this is a really good first program, right, beyond our hello world for something like the circuit playground. It hits a lot of core programming concepts. The only thing we don't get into here that I want to touch on with our next project is arrays and maybe creating our own functions, but there's a lot packed into a little bit here, right? And speaking of a lot packed into a little bit, let's go back to sort of the key topic of this video, which is variables. One other thing about variables that I want to get across in this video. So if one of them is, I want you to start every program thinking, what should my first variable be, right? The first thing we coded with this game was the variable light position. And I want you to do that with most of your programs. I want you to think, what's the first variable I need to code before you put any other code down? What's my first variable going to be? Because that's probably going to be the most important part of starting your program. And then the second thing I said was every time you make a variable, go ahead and set that immediately in your code. So you don't forget. Set it to something, 0, 1, whatever. The third thing I want you to think about when you're starting to work on variables is where can I put them? What could be a variable that's not already, right? Because if we look at each of these bubbles, we want to get as much of these white bubbles away. So every time we see a white bubble, we need to think, could it be a variable? So here we're setting variables. We're setting the variables. So obviously those can't be it. So the ones that can't be it, I'm going to just point at them with a red arrow. So we set the variable there. Probably no point in changing those, right? And then here we're checking if A was pressed. So, we're checking if A wasn't pressed. So we probably want that to be a 0. At increasing the light by 1, definitely going to want to do that. And then checking if it's 9 and then setting it back to 0. We need to do all of those. When the A button is pressed, we need to make the 0 go to a 1. Definitely need that. And what else? Putting it back to 0. So that really leaves us with our target pixel, the amount of time we pause between turning the lights on and off. So let me do these in a different color so it's a little more clear. Let's do them in blue. So this could probably be a variable. So could this. And so could this, because the 2 is the same as the 2 here. These two are the same. These two are linked by the same logic, right? This is how we win. And then the animation time, right? We could make those variables because, maybe we want to change those. And when we change them, we want to change them at the same time. And that's the important part of this exercise of checking for what can be a variable, because if our target pixel, let's do the one where we say where we win, right? We win at position 2. So we'd light up. So we're lighting that up as yellow. And we're checking if we stopped on 2. And if I change one and forget to change the other, I completely broke my game, because now I'm telling the player, I'm highlighting yellow to the player that's probably where they should stop, but this is different. We want to avoid that. So we should definitely create a new variable here called target pixel. And feel free to use your own variable names if you don't like mine. As I was saying with the labeled boxes, creating variable names is not an exact science. Sometimes it's pretty obvious what it should be called, but a lot of times you're going to need to, there are going to be several names that you could choose. Don't get hung up forever on what the best variable name is, but always try to make it something that makes sense. So now here I can set target variable to 2. And if I want to, I can now set that target pixel here, put the target pixel here. And now if I want to ever change the target pixel, I only have to change it here, and both of these update. And additionally, I can now make this game a little bit more dynamic. What if every time we won, we moved the target pixel, right? Set target pixel 2, and then we put some random number in, right? I love that. I love me some random numbers. So now we could set target pixel 2, pick random 0 to 9. Now, every time I win, I lost there. So I have to actually be good at my own game to do this. There we go. Every time I win, the pixel moves around. Pretty cool. Now, the other thing we could do is, the other thing that should probably be a variable here is the pausing of the time, right? This is a key part of our game. This is how fast the pixel goes around the screen. The smaller this number is, the faster the pixel is going to move around the screen. So we can actually put in some difficulty here. So if I create another variable, we call it speed. And I set speed to, let's say 75. 100's a little slow. So we set speed to 75 at the very beginning. And we put speed into our pauses. Now our pixel's a little faster. And now I only have to change it here if I ever wanted to change it, right? I can make it really fast by making it 25 instead. Or really slow by making it 200. Just like that. But if I keep it at 75, I can also make this dynamic as in another way. So now, not only will the light position change every time I win, but also every time I win, I can decrease, change speed by -20. I can make the game harder by making it faster every time we win, which again, I have to actually win to do that. There we go. So now the light moves around and the pixel gets faster. Now it's very difficult. I'm not going to try to. I'll try one more time. This video is already long. There you go. I couldn't do it. But anyway, now one thing to be worried about here, I'll leave this here for now. I'm not going to fix it, but be careful with this. Pauses can't be less than 0. So you'll have to do maybe an if statement here to check that, you know, if less than 0, then, you know, maybe you just reset the game. Maybe you change up the winning animation a little bit to say, okay, now like not only did you win all those other times, you really won because you beat all the levels, and then you can reset the game, put speed back to 75 and let them try to do it again. So I hope this video was useful. Again, not a lot of code, but this is a long video because there's really a lot to say when you're first learning variables. So I really want you to be able to watch this video or rewatch this video if you ever need to come back and learn how variables work, what they do, why we use them, how to think about them, and then maybe you could start implementing them a little bit more in some of your own programs, which I would love to see. So I'll leave it at that. As always, I hope this video helped, and I will see you in the next one.